2a, 2b, and 2c all look very similar to one another, but they're going to require completely different techniques of integration. This first one, again, I'm looking at the bottom, and I don't immediately go to arctangent. I look at it and I go, okay, can the bottom, because it's all being raised to the 1 power, can I use du over u? Can I use a natural log? But because the derivative of this is 2x, I don't have an extra x up here. I'm going to have to apply arctangent. I'm going to establish u squared as being x squared, so that means u is x, and that means du is, of course, dx. So a squared is 9, that means a is 3. Now, you do have an extra 4 as a coefficient here, so you can factor out the 4 if you'd like to, or you can leave the 4 there, but either way, don't forget about it. The 4 is definitely a part of what we are doing. So now you could rewrite this. I don't think it's going to help you much, but you could rewrite this as du over u squared plus a squared to see that. But there's not any extra coefficients lingering, so you shouldn't get all tripped up with that. So this step is not required, but just don't forget about the 4. So we're going to have 4, and then this is arctan, so we have the 1 over a. 1 over 3 arctan of u over a, which is x over 3, plus c. So the only thing we can do is multiply that 4 and 1/3 together in order to simplify this. So the technique of integration on this one was using inverse trig. 2b is really similar, but in the top I have an x. You knew how to do this question, probably with significant confidence, before today. But now that I've given you inverse trig, now you're a little hesitant. When you see that bottom part, don't immediately think inverse trig. Don't go to arctan yet. Look at this and say, okay, could this be u? Could this be a du over u situation? And in this case, it can. You can establish u as being x squared plus 9, but your du takes care of that x right here. So that x dx is going to be taken care of. So my only issue right now is the 4. You could multiply both of these sides by 2. But either way, you're going to get the same thing. If you had established this as 1/2 du is equal to x dx, that would have been fine as well. But you would be multiplying the 4 by the 1/2. So those two would end up multiplied together. In this case, I'm just replacing all of it with 2 du. So we're going to set this up. I'm going to erase that circle there. All of this is going to get replaced with 2 du. So I've got the 2 on the outside, du, and then u is on the bottom. That's a natural log. So I've got 2 natural log of x squared plus 9. Remember, the absolute values are not required because I have always a positive value here. This is x squared plus 9. All of that is going to be positive no matter what. You could use absolute value, but you don't have to. Now, the next question is a little bit more challenging. When I see that 4x squared in the top, that makes me hesitate a little bit. Part of the reasoning is because I know arctan doesn't work, and I know that regular u sub, even with a natural log, is not going to work. You don't have another option except to try long division. Because these are both the same exponent, that means I could divide this denominator into the numerator. Remember, the denominator either has to be smaller exponent or equal to for us to be able to do long algebraic division. One of the reminders about doing long division is to make sure that you fill in those missing terms. So you need a 0x there, and then you're also going to have to fill in missing terms for the top piece. Now, it's not going to be overcomplicated long division. There's not much going on, honestly. So what I'm going to do is I'm going to ask, what do I multiply x squared by to give me 4x squared? And I'm multiplying by 4. Oh, I hope that y'all caught that. That was just supposed to be a 0. That's a constant term. So if it's just supposed to multiply by 4, I'm going to put the 4 here because this is my constant term kind of column. So then I multiply. 4 times x squared is 4x squared. Scroll that up a little bit. 4 times 0x is, of course, 0x. And then 4 times 9 is 36. Remember, you're supposed to subtract these. So I'm going to apply subtraction. The zeros aren't going to matter. But then I am going to subtract 36 from 0. So that's going to be a negative 36. Remember, that's your remainder. And the way we rewrite this as an integral is that we include this as division over x squared plus 9. So I'm going to rewrite, trying to change my color here. I'm going to rewrite this as the integral of 4 minus 36 over x squared plus 9. That's the remainder part. Now you may need to break this up into two integrals in order to see it well. You integrate 4 dx minus the integral of 36 over x squared plus 9. Remember, dx. If you are integrating, you better have a dx on there. I know how to integrate 4. That's just going to be 4x. This requires a specific technique of integration. Again, I'm looking at a situation where there is no x in the numerator. So this is going to be arctangent. This is exactly like 2a, except I have a 36 instead of a 4. But it's just a constant. So I'm looking at a very similar setup, and certainly the same process. So we're going to say that this is 4x. And then this 36, I can move to the outside. U squared was x squared, so that means u is going to be x. A squared was 9, so that means a is going to be 3. I do need the 1 over a. That's part of the formula. So we're going to multiply by 1/3. We're going to have arctan of u over a, which is x over 3. And then the only thing I can do to simplify this is multiply the 36 times 1/3. So applying the long division created an arctan situation, right? We had this arctangent, but we did have to get that constant in order to be able to clean everything up.